the two batteries of EMF E2 and internal resistance are connected in parallel, the effective EMF across circuit A and B. So effective EMF means E equivalent, and of course one thing is missing here, that batteries are connected in same polarity or opposite polarity. So because they are in parallel, it is given to us they are connected in parallel. We know E1R2 plus E2R1 upon R1 plus R2, E1R2 plus E2R1 upon R1 plus R2 directly. So this is very, very helpful result, my dear student. You can directly apply in many questions, as you will see in this. Now let us say this question. Now in this question, the circuit shown in the figure, the value of R must be. So basically these two are the grounding, these two are the 0 voltage, 0 voltage. So basically when 2 points are grounded, it is equivalent that they are connected to each other. So it is a closed loop, and we are given 1 ampere current. The direction of 1 ampere you can see is like this. The direction of 1 ampere will be like this. So it is very simple to solve. They are asking us what is the value of R. So all of them are in series, effectively all of them are in series, You might be wondering, sir, why have you joined this? Because, my dear students, basically both are at the same potential. So when both are at the same potential, we can directly connect them. So and we also know that current which is going inward must be current outward by conservation of current. The current will be same, so it's like a simple series circuit. So you can just you can visualize it as there is a simple series circuit. So whenever two batteries are connected at the same at two different points, you can directly connect them like this. So in this case, if I write the current, I will become total voltage, total EMF is only, there is only one battery, 12 upon total resistance. So total resistance is R plus 4 plus 3. So that is R plus 4 plus 3, and the value of current is 1 ampere. So this thing is equal to 1 ampere. So just solve. From here you can see 12 equal to R plus 7. So you get R will be equal to 5 ohm. Standard simple question. Okay. No need to apply KVL and so on. Just apply the basic understanding. Now let us go to the next one. A battery has EMF of 4 volt, EMF, it is the EMF, okay. So E is 4 volt, and internal resistance R, internal resistance is not known to us, it is given to us as R. When this battery is connected to an external resistance of 2 ohm, so battery is connected to the external resistance of 2 ohm. So this is the external resistance, this is capital R, this is internal resistance, and that is battery EMF is 4 volt. Then 1 ampere of current flows it, 1 ampere of current. So basically we know the current in this circuit as E is equal to E upon R plus small r. So first equation is 1 equal to 4 upon when you have connected 2 ohms, so that is 2 plus small r. So from here you get small r will be equal to 2 ohm by solving this. Now what they are saying, how much current will flow if the terminal of the battery are connected directly? How much current will flow if the terminal of the voltage are connected directly? What does this mean? Basically, this is the internal resistance, this is the battery, EMF E 4 volt, or internal resistance we already know is 2 ohm, we have determined. Now if the terminals of the battery, these are the terminals of the battery, are connected directly means the external resistance is 0, you have short circuited it. So when the external resistance is 0, you can see current will become E upon small r plus 0. E we already know is 4, internal resistance we have just calculated is 2, so current will be 2 ampere, that is. So you have to visualize what is given. The questions, the problems will be given, will be from all the concept which we have done, they will come only from them. You have to visualize, okay, internal resistance, potential difference, a combination of cells. You just have to identify which case this is, that is all. Now let us go to the next one. Yes, this one. In this case again you can see there is a battery, there are multiple batteries. This is given as 0 volt, and they are asking the current through the 5 ohm resistance. We need to find the current through 5 ohm resistance. So basically, my dear students, in this case you can solve it using many methods, but one of the method is easy to use. One is, whenever you can see the batteries are connected, always try to identify the nodes, where 2 or more branches are connected. So these are the nodes, and then write the potential of these nodes. So we know this node, the lowest one, this is 1, 2, 3, 4, the potential of 1 is already 0. Now because this node is directly connected via battery, there is no resistance in between them, so we can write the potential at 2 as directly, we can write the potential at node 2 directly as, you can see, if this is 0, this will become plus 4 volt. I think you can see the battery is connected and no internal resistance, so this is 0 and directly 4 volt. Now from that node, now basically from this node we can go down here, and you can see this time a 6 volt battery is connected in opposite polarity. So from plus 4 to, when you go there, 4 plus 4 minus 6, this become minus 2 volt, and then from here to here you can go again, 8 volt is connected with opposite polarity, you are going from high to low, so you have to subtract 8, so that will become minus 10 volt. So that's all, my dear student. Now you know the 5 ohm resistance, this is the 5 ohm resistance, and one of the end is at 4 volt and the other end is at minus 10 volt. So you can see clearly, this is high, this is low, so the current will flow from high to low. How much current will flow? Current will flow with the potential difference 4 minus of minus 10 upon 5. 4 minus of minus 10 upon 5, so this will become 14 by 5, so this will be basically 2.8 ampere. Beautiful question. Again, I haven't used any KCL KVL, because if you apply the KVL here, 2 equations will come and it will become difficult for you to solve again and again. You will get the same answers, of course, but it takes, this is called as nodal analysis. This is very quick and fast and accurate. Let us go to the next problem. Is this one. So what they are asking, a current of 2 ampere flows in the system, the potential difference A and B. So basically 2 ampere current is given to here, and we need to find the potential difference at A and B. So how do we write the potential difference in this case when the current is given? So basically, my dear student, to write the potential difference, you have to first distribute the current. Let's say the current here is I1 and current here is I2. You already know the distribution of current. How do you write the current? If you see carefully, if you observe it carefully, the distribution of the current I1 will be equal to I2. Why? You will say, sir, there is only 2 ohm. No. When you write the distribution, you have to consider the complete resistance of this with complete resistance of this. Okay, so both are 5 ohms. This is also 2 plus 3, 5. This is 2 plus 3, 5. So it means the current I1 will be equal to 1 ampere and I2 will also be equal to 2 ampere. So basically now you know the direction of current. The current will be flowing 1 ampere each. So now to write the potential difference, you can directly apply. Let us say this point is at potential VA and this point is at potential VB. So I can go from VA to D and then D to VB. I can apply the KVL directly. Look, I am not applying KVL in complete loop. I am just applying the potential difference between these 2 points. So basically, you know the direction of current. You already know 1 ampere is flowing from, this is high and this is low for this resistance, and similarly for the other one 3 ohm, this is high and this is low. So when you go from A, VA is at low, and when you come at D is high when you cross this. So VA plus how much current is 1 ampere, resistance is 2, so plus 2 into 1. So you have arrived at D. Now you will go from D to B. You know D to B, in D and B, which one is at low? B is at low. That means you have to subtract. By how much amount? I into R. I is again 1 ampere and R is 3 ohm. R is 3 ohm. So this is minus 3 into 1, and finally you will arrive at B. Okay. So potential difference, you can clearly see this is 2 minus 3 is minus 1. So VA minus VB will be equal to 1 volt plus 1 volt. Beautiful question, application of KCL and KVL both. Now let us solve this one. Again, potential of point E is what we need to find. We need to find the potential of this point E. Again, this is a closed circuit. You can see this is the 0 volt. And if you want to write potential of D, this is all 0 volt. But to write the potential of E, you need to see the direction of current, because the only one battery is connecting, so current will flow like this. No current will go to the earth, because my dear student, otherwise the KCL will not be valid. The current will only flow within this circuit. If you assume that some current, X current goes in it, then when you apply the Kirchhoff current law, you will say that X must be 0, only then the KCL is valid throughout the loop. So current in this case, you can say all of them are in series, so total current I will become, total voltage EMF is 8, and add all the resistances, 1 plus 5, that is 6. So this will be 4 by 3 ampere. Okay. So now we have to apply, we have to reach from C to D and then D to E. We know both are at the same level, so VC and VD no change. But when you go from D to E, you are going in the direction of current, you can see. So this is high and this is low. So when you go from high to low, potential should decrease by what? So V at C minus 0 minus the current is 4 by 3 into 1 is equal to potential at E. Now V at C is 0, so 0 minus 4 by 3 is equal to V at E. So potential at E is minus 4 by 3. Simple. KCL and KVL both are being applied here simultaneously. Now let us solve this one. So what is given to us? A EMF of 10 volt is connected to the resistance as shown in figure. The potential difference VA minus VB between points A and B will be. So my dear students, we have to find potential difference between A and B. So for that, you need to see you need to find the potential of these 2 points. Then you can apply the distribution method, but we don't know the potential of these 2 points. Then what is the other way? Basically the other way could be to write the current and then go from A to B inside it. Again, if you observe carefully, this is also 1 and 1 plus 3 is 4, and this is also 3 plus 1 is 4. So basically equal amount of the current will distribute. Suppose if I current flows, then I by 2 will go up and I by 2 will go down. It's a simple problem. So if you write the current I, you have to find the equivalent resistance. So that is, you have to solve this. So this is 4 and 4 are in parallel, 2 and 3 will become 5 series. So current will be 10 upon 5, that is 2 ampere. Now we know 1 ampere will go upward and 1 ampere will go downward. So clearly you can identify, if you go from A to B, you can clearly see potential at A. So when you go from A to B, you have to come opposite to current. So plus 1 into 1 and then minus 3 into 1 will be equal to VB. So you can see VA minus VB will be equal to 2 volts, similar to what we have done earlier, but in this case it was, we also have to find the current. It was the extension of the previous question which we had done. Now this one, this is again a beautiful problem. 9 volt battery is connected to 1, 2, 3, 4, 5, 6, 7, 8 and 9 resistances and each of value 9 ohm. Now my dear students, because all of them are parallel, you can clearly see this is 0, 9 volt, each is between 9 volt and 0 volt, each is between 9 volt and 0 volt. Ammeter can be assumed as 0 resistor. So the current will be same in each, same current will flow in each branch, and the current, the value of current will be equal to 9 by 9 will be equal to 1 ampere. So 1 ampere current will flow through each branch. Now but we want the reading of ammeter. So now imagine if each of this branch will give 1 ampere each, all of them gets added and pass through this. So 1, 2, 3, 4, 5, all 5 of them will gets added and will pass through this. So here 5 ampere, and you can also determine then 5 ampere, then these force will also get added and this become 9 ampere. So battery will provide 9 ampere current, 1, 1, 1 to each. So reading of ammeter will be 5 ampere. Again a beautiful question. This one. VAB, the potential difference between A and B is given to us as 4 volt, and they want us to identify the resistance X. So basically, my dear student, if you can identify when these two, don't you think it is the parallel combination of cells? So when we combine them, what comes out the effective resistance between, what comes out the effective voltage between them? Equivalent. The effective voltage between them was equivalent. So VAB, we can directly write VAB will be equal to E1 R2 plus E2 R1 upon R1 plus R2. That's all. So apply the formula. So what is VAB is given as 4, E1 R2, E1 is, now consider, because both of them are connected, positive is connected to the same left hand side. So E1 R2, so 4 will be equal to E1 R2. So 5 into X plus E2 R1, 2 into 10, 2 into 10 upon R1 plus R2. What is R1 and R2? What is R1 is 10 and R2 is X. That's all. So multiply across, so that will become 40 plus 4X will become 5X plus 20. So by solving this, you will get X equal to 20 ohm directly. Yeah, you have to visualize what they are giving. It's just by observing you can see they are giving us E equivalent is given and we have to find R2. Now let us go to the next problem. This one. This is basically based upon the distribution. So circuit shown in the figure, the current through 3 ohm and 4, you have to solve this circuit. But it looks very big, but it is very easy. If you can see this 2 ohm, 4 ohm and 8 ohm, they combine to form 2 plus 2, 4 plus 4, 8 ohm. Now with this 8 ohm, if you combine this 8 ohm, this together will again become 8 ohm with parallel with 8 ohm, this will become 4 ohm. And when you combine this 4 ohm again with 2 ohm and 2 ohm, all of them will become again 8 ohm. I hope you are able to identify what I am doing. And then again this complete 8 ohm combines with this 8 ohm and it becomes 4 ohm. Okay, and this 4 ohm plus this 3 ohm plus this 2 ohm, you can see they are in series. So 4 plus 5, so effective R equivalent comes out to be 9 ohm. So this is how we determine the R equivalent. Now let us distribute. So if the R equivalent is 9 ohm, you can see the current will be 9 volt upon 9 ohm, that is 1 ampere. This is 1 ampere current. So 1 ampere current passes through 3 ohm. So 3 ohm resistance will have 1 ampere current. So these two options will be wrong directly, because 3 ohm resistance has 1 ampere current and none of them is given as 1 ampere. Now this 1 ampere when passes through at this point, it distributes into 2 branches. We know this branch, the 1 ampere distributes in this branch, and you can clearly see, my dear students, this 1 ampere gets distributed equally in both the branches, because the red one was equivalent to 8 ohm and this is also 8 ohm. So 1 by 2 ampere comes here and 1 by 2 ampere goes there. 1 by 2, 1 by 2 ampere goes there. So basically 1 by 2 comes here, 1 by 2 ampere, and again at this point it gets distributed into 2 branches which are also equal. The yellow one is also 8, this one is also 8. So this is 1 by 4 ampere and 1 by 4 ampere. So this is 1 by 4 ampere, 1 by 4 ampere, and so on and so on. So now let us determine the current through 4 ohm resistance will be 1 by 4 ampere. So option number. Again a beautiful question. I hope you understood the concept. Distribution of current, that's all. Yes. So what is given? In a given circuit, the steady current, the potential drop across the capacitor must be. So you can clearly see, my dear students, again these are the two batteries and resistances which are connected like this. These two batteries are connected in parallel. So we can combine them to write the potential difference across this point, or you can directly write the potential difference of V and AB. What is VAB? VAB will be equal to E1 R2 plus E2 R1 upon R1 plus R2, combination of cells. So basically both are connected positively to here, positive to there. So VAB where B is positive, so this will become E1 is V into 2R plus E2 is 2V into R upon 3R. So this will become V into 2R, that is, this is 4V by 3, where VB minus VA, VB is at high voltage. So now the question becomes that there is a battery V and there is a capacitor C, and this is position A and this is position B, potential B, and we know the potential difference across this is 4 by 3 volt. Okay, 4 by 3 volt. So you can see the potential will distribute between this battery and this cell. So total voltage V plus potential across this VC, V plus VC should be equal to VB minus VA, that is 4 by 3 V. So clearly you can see potential difference across C will be V by 3. So potential difference across C, again a beautiful question. Multiple concepts are being applied here together. Now let us go to the next problem. This is the direct one. This is the, you can see voltage versus R graph. So voltage versus R graph, C option directly. When R is 0, voltage 0, potential difference across cell. Directly you can apply this question. This is wrong because this is not V versus I, this is V versus R, so that's why second is option. If this would have been V versus I, then this also might have a correct option, but in this case it is V versus R graph, so directly C option. So we have reached the limit. So basically this is current electricity, my dear students, and if you ask me what is the importance of current electricity, then on an average 2 to 3 questions are coming from this topic. So now let's go ahead with the next topics, that is the power and the instruments in electric current.